Okay, guys, we're going to be doing paper 2 for June 2023, pure for Edexcel. Let's get started. Question 1. We've got, part A is asking us to find the second derivative of this expression. Well, to work out the first derivative, this is just going to be equal to 3x squared plus 4x minus 8. Okay, and then I should probably write f prime x is equal to this. Therefore, f prime prime x, or our second derivative, would be this expression differentiated again, so that'd be 6x plus 4. Perfect. And then part B is saying that solve for it to equal to 0. So we're just going to be doing 6x plus 4 is equal to 0. Therefore, x is equal to minus 4 divided by 6. And this can be simplified to minus 2/3. Now the question is asking us, hence find the range of the values of x for which f of x is concave. So what this essentially represents is that because when we have a d2y over dx squared is equal to 0, essentially what you work out is it's kind of its point of inflection. And because our original graph is a cubic graph, however it looks like, let's say for example it looks like this. Let's just say it looks like this, right? This point here will be essentially x is equal to minus 2/3, where it's kind of like not, well, you can see this is decreasing here and then it begins to increase at this point. So this is going to be our point of inflection. Now you can see here that because our cubic is a positive cubic, we are going to have a cubic in this shape. We're not going to have a cubic going downwards like so. We're not going to have this, but we need a cubic going in the upwards direction, okay, because it's a positive x cubed. Now we need to determine what is our kind of range of values of x, which is concave. Now this is how I kind of remember this. Concave essentially looks like a cave, okay, and then sorry for the glitching, I don't know why it's doing that. And then convex would just be opposite. So this is going to be a convex shape of a graph, and it's going to be a concave shape of a graph, okay. And because the question is asking us hence find the values of x for which f of x is concave, and this is kind of our point of inflection, essentially you can see that this region here must be our concave region. So our final answer must then be x is less than minus 2/3. Now it doesn't really ask us about set notation or anything, but I'll show you how to quickly do this. It's very, very simple, to be honest. You're just going to do x is real, okay, make sure you have your little curly brackets, a line like that, and you can say x is less than minus 2/3. Easy marks for set notation, but it doesn't really ask us, so it doesn't really matter. You can just put this and you'll be completely fine. Question 2. A sequence u1, u2, u3 is defined by the following. We've got u1 is equal to 35, and then we've got this mess here. Okay, show that u2 is equal to 40. Alright, so if we know that u1 is equal to 35, and we're trying to work out u2, okay, let's use this formula for part I. Now, this is un, so if un plus 1 is equal to u2, that means that n has to equal to 1. So that means that this part here must be essentially 35. Okay, so we're going to do 35, and essentially I'm just putting this 35 into this formula here, and n will essentially equal to 1 as well, basically. Okay, so we're going to do 35 plus 7 cos of, well, 1 times by pi is just pi, over 2, minus 5 to the minus 1 to the power of 1, because again, n is 1. Now what I'm going to do is just put this right into my calculator, like so. And when we have expressions like this, I would recommend that you guys kind of expand this out almost separately. So what I mean by that essentially is we have 7 cos, and actually because we have a pi over 2, we should be in radians. Do not use degrees, okay, use radians. So 7 cos pi over 2. If you ever see pi, is probably going to be radians. Well, this is just 0, okay, and so this is going to be actually 35 plus 0. Well, minus 5 times by minus 1 is actually just 5, so that's plus 5. Therefore, this is equal to 40. Amazing. Find the value of u3 and u4. Well, because it's kind of an iteration, well, not necessarily an iteration, but they've given us kind of this, this recursion almost sequence. I think recursion is probably the best word. The word's not coming to my mind. Maybe it's just iteration. And the word, I can't think of the correct word. Anyways, part 2 of this question. Find the value of u3 and u4. So essentially we're just going to be using the same method, and this time we're just plugging in 40. So u3, this time n is going to equal to 2, and then we'll worry about u4 in a second. Okay, so this time, here we have un, this time we're going to be using u2, so we're just taking 40 to the next kind of formula, plus 7 cos of, now why have I used 7 cos? Just from the formula, and this time is going to equal to 2, so this is going to be 2 pi over 2, which is just pi, okay, minus 5 times by minus 1 to the n, which is squared. Okay, let's try to simplify this a bit more. 40 plus, well, 7 cos of pi. Your cos graph kind of looks like this. This is 0, 90, 180. Well, 180 is pi. So it's going to be minus 1. Therefore, this should give you minus 7. And you can always just plug that into your calculator as well. This is going to be minus 5 times by 1, because minus 1 squared is 1. That gives you minus 5. Therefore, this is going to be 40 minus 12, which is going to be 28. So u3 is equal to 28. And then again, we're just going to do the exact same thing. U4 this time, we're going to have n equals to 3. We're going to have 28 plus 7 cos of. This time n is equal to 3. So that's going to be 3 pi over 2. Minus 5 minus 1 times by minus 1 to the power of 3. Let me just double check that. Yep. We are good. And then we just go ahead and simplify. I'm just going to draw my cos graph again. 0, 90, 180, 270. So at 270 it is 0. So you have 28 plus 0. Well, minus 1 cubed is essentially minus 1. So minus 5 times by minus 1 gives you plus 5. That should give you 33. So u4 is equal to 33. That is good 3 marks. Given that the sequence is periodic with order 4, write down the value of u5. So essentially what order means is that, let me actually rewrite this. So u1 is equal to 35, u2 is equal to 40, u3 is equal to 28, I believe. Yeah, and then u4 is equal to 33. So when it has order 4, essentially what this means is that every 4 numbers is going to repeat. So u5, that means, has to be this start bit again, and just the cycle goes ahead and repeats. So that means that u5 just has to be 35. And you can double check this as well. Plug 33 into the equation and you should still end up with 35. Okay. Alright. I'm going to take a screenshot of this for part BII. And yeah, let's just keep it here. So essentially what this means is you have u1 plus u2 plus u3 plus u4 all the way to u25. Okay, and this can be a bit tedious if you're trying to do it manually, like trying to work out u1, u2, u3, u4. And this is where your order comes into play. Okay, a lot of these sequences, especially when you have this in your paper, you will have an order. If you don't, then there will be some sort of other trick, potentially with logs, or I've seen stuff with logs. But with the order 4, essentially what we can do is be able to simplify these terms. So when we have 25 terms, well, within the 25 terms, how many, trying to phrase this correctly, how many 4s do we have? Almost. Well, 4 times by 6 gives us 24, right? And then we have a little bit excess. Okay, so that essentially means we have 6 of these, and then we just have 1 of these. Okay, so essentially what we can do is 6 times by u1 plus u2 plus u3 plus u4, because we know it's just going to repeat anyways. It's going to go u5, u6, u7, u8, which is the same thing as this anyways, okay, because it repeats. Okay, but then after u4, what does it have to start again to? Back to u1, okay, which is essentially this. And that's, if you count this up, this is going to be 24 terms plus 1 term. That gives us 25 terms, which we want. Okay, well, we can work this out pretty nicely. Well, this just adds up to, no idea. I'm going to use my calculator. 35 plus 40 plus 28 plus 33, 136. So 6 times by 136 plus, well, u1 is going to be 35. Okay, that's going to give us 36, 180. That's going to be 216, 216, 600, 816 plus 35. That gives you 851, I believe so. Yes. And let me write my 5s a bit more nicer because they look a bit ugly. There we go. And that should be your final answer. Question 3. We've got logs question here. Part A shows, well, is asking for this sort of quadratic. The first kind of impression I have is to essentially combine all our logs together. So with our log laws, whenever you have some sort of addition of logs, okay, you should really try to simplify them like so, because you can just go ahead and multiply. So that's what I'm exactly going to do with this. So this gives me log 2 of x plus 3 times by x plus 10 is equal to, my brackets are messing around here, there we go, it's equal to 2 plus 2 log 2x. And I kind of want to combine all the logs together. So what I'm going to do as well is, because we have this coefficient here and no coefficient here, I'm going to get rid of this coefficient by essentially making it into a power. And this pen is horrendously fat. There we go. And this just essentially becomes x squared. And then what I'm going to do is move this to the left hand side. So this becomes log 2 x plus 3 x plus 10 is equal to 2. I completely forgot to minus, sorry. So this becomes log 2 x plus 3 x plus 10 minus log base 2 x squared is equal to 2. And another one of our log laws, when you have a log subtract another one, kind of like your opposite of this, this is the same thing as your division. Okay, so what I'm going to do is move this x squared to a denominator. So this becomes log base 2 x plus 3 times by x plus 10 on our numerator, all divided by x squared on our denominator is equal to 2. I'm going to make this log 2, well, how can we get rid of this log 2 actually? Well, the opposite of log 2 is just base 2. Okay, so I'm going to base 2 both sides. So this becomes x plus 3 x plus 10 all over x squared is equal to 2 from our log 2 to the power of 2. Okay, that just becomes that power. And then I'm just going to expand and rearrange. So this becomes x squared plus 13x plus 30. That's a numerator expanded out. Over x squared is equal to 4 times by x squared on both sides. This gives us x squared plus 13x plus 30 is equal to 4x squared. And we can move everything to one side. So this becomes 4x squared minus 13x minus 30 is equal. And we can move everything to one hand side. I'm going to subtract this x squared. So this becomes 3x squared minus 13x minus 30 is equal to 0. Amazing. That's part A complete. Part B, write down the roots of this equation. So essentially we can just put this into our calculator. But again, make sure you try to put some sort of factorizing or some sort of method to show that you're working it out. In this case, it is a 2 marker, I believe. So I don't think they'll be too fussed about it. But here we've got 6 and minus 5 over 3. So I'm going to kind of fake it. So this becomes 3x plus 5 and x minus 6. So there we get x minus 5 over 3 and x equals 6. Okay, so I've kind of just gone backwards to quote unquote factorize it, which is cool. I'm just going to double check my factorizing, and yeah, that's cool. All right, now if we go back to our logs, which log should not be our answer? Well, you can see we have a log x here. And if you're ever unsure, just put both of your answers into the original equation. We cannot have a negative log, so we cannot have this. Therefore, x is only 6. Okay, as log value, or I should say argument, cannot be negative. Okay, otherwise you'll get some sort of imaginary number or just an error in your calculator. Cool. Part 4. Coffee is poured into a cup. The temperature of the coffee, H degrees Celsius, T minutes after being poured into the cup, is modeled by the equation this. Initially, the temperature of the coffee was 85 degrees Celsius. State the value of A. Okay, so essentially that means that when your time is 0, your temperature given by H is going to equal to 85. Therefore, H must equal to AE to the 0 plus 30. But remember, whenever you have anything to the power of 0, it's just 1. So we just end up with A plus 30, and it is actually 85 is equal to that. Therefore, if we go ahead and rearrange, A must equal to 55, which is pretty nice. Cool. Initially, the coffee was cooling at a rate of 7.5 degrees per minute. Find a complete equation linking H and T, giving the value of B to 3 decimal places. So if you ever have the word rate, you want to think dy by dx, or in this case, you're going to be using dH by dt. It doesn't really make a difference. Okay, so I'm actually going to go ahead and rearrange, or actually rewrite the original equation in terms of including A. So I have H is equal to 55e to the minus bt plus 30. And then what I'm going to do is work out dH by dt. The reason why I'm doing this is so I can go ahead and kind of include this information to help us work out B. Well, dH over dt, we're going to differentiate this using chain rule. Okay, so we're going to do 55 times by the differential of minus bt. Well, the differential of minus bt just goes to minus b if you're doing d over dt. Okay, so essentially this becomes minus 55b, and then all your exponential stuff just remains the same, e to the minus bt, and 30 just differentiates to nothing, 0. So you just leave it like this, which is cool. All right, it says that when initially always means t is equal to 0, by the way. The coffee was cooling at a rate of 7.5 degrees per minute. So if the coffee is cooling, that means our temperature is decreasing. Okay, so that means this is going to essentially be negative, and this will probably take account of this in some way. But this essentially means that when t is 0, our dH over dt must equal to minus 7.5. So I'm going to go ahead and put this t into here. Again, this is actually very, very similar to what we did in part A. So this becomes e to the 0, which is just 1. Therefore, minus 55b must equal to minus 7.5. Now we can go ahead and rearrange for this in our calculator, and this becomes 7.5 divided by 55. Kind of just took away the minuses. That gives us 3 over 22. Or it says it in 3 decimal places as 0.136. Question 5. The curve C has equation y equals f of x, and we've got that it passes through the point 3 minus 10, and it has a turning point at P. So that means that when x is equal to 3, our dy by dx must equal to 0. Given that our dy by dx, so we've been given a dy by dx equation, is equal to 2x cubed minus 9x squared plus blah blah blah, this is a cubic, we need to find that k is equal to 12. Okay. So this is actually a cubic equation. That means that our original equation is probably going to be x to the power of 4, maybe with some coefficients or whatever. All right, I'm going to start with this information actually. Okay, so this is just going to give us 0 is equal to 2 times by 3 cubed. So I'm essentially just plugging this information into here. Minus 9 3 squared plus 5 times by 3 plus k. Let's expand out. So this becomes 27 times 2, which is 54. This becomes 9 times 9, which is minus 81, plus 15, plus k is equal to 0. Let's put everything into our calculator and kind of simplify it. This becomes 54 minus 81 plus 15. That means that k minus 12 is equal to 0. Therefore, k is equal to 12. Part A, very, very nice. Now, part B, we need to work out potentially the whole equation, but let's see. Hence, find the coordinates of the point where C crosses the y-axis, so our original quartic. So we should really go ahead and integrate this. But I'm actually going to start by rewriting the original equation, like so. And then that means that y is equal to then x to the power of 4, but then we need to divide, so that's going to be a half, minus x cubed, 9 divided by 3 gives you 3, plus x squared, that's going to be 5 over 2, plus 12x, plus, let's use c. Okay, now we've got this point, 3 minus 10. And essentially we're working out the value of c. So we just substitute 3 minus 10 into these into this equation, and that's going to give us minus 10 is equal to a half times by 3 to the power of 4 minus 3 to the power of 3 cubed plus 5 over 2 3 squared plus 12 times by 3 plus c. And we need to go ahead and rearrange this for c, and I'll quickly type that into the calculator. A half times by 3 to the power of 4 minus 3 times by, I'm going to put 27 just so I'm just lazy, 5 over 2 times by 9 plus 36. Cool, so that gives us minus 10 is equal to 18 plus c. Therefore, c must equal to minus 28. Our coordinate of the point, because it's asking us in terms of a coordinate, since it's a y-intercept, it's just going to be 0 minus 28. Okay, since it's the y-intercept, whatever it looks like. That's definitely off the point. There we go. Cool, very nice. Question 6. We've got 4 vectors here, a, b, c, and d, and each of these has an I and j component. Show that AD is parallel to BC. First of all, what do these essentially mean? Well, these are not even vectors, these are actually points on a grid. So so if this is origin, A is like 12. So that means that this is represented by OA, this is represented by OB, this is represented by OC and OD. Okay, these are all from origin to that specific point. So if you want to work out, for example, the question is asking us AD, well, if A is here and then D is what, 22i and 24j, which is probably like here, this is D and this is A. How can we work out AD? Well, that's essentially going back to the origin and then up. So we're going to have OA, we're going to have AO plus OD, which gives us AD. You can see going back from A back to the origin up to there. Okay, and sometimes drawing it can be helpful. It doesn't have to be necessarily accurate, like I've kind of just made a quick sketch. And this is going to be AD. So AO, as we've written down, we're going to flip around. So if OA is equal to 12i, that means that A to O must be minus 12i. It gets flipped around. OD is still the same, so that's going to be plus 22i plus 24j. And we simplify this, this becomes 10i plus 24j. Now the question is also asking about BC. So BC, well, what other vector have we kind of used, or sorry, points we've used our origin. So this is going to be the same thing as B to O plus O to C. Well, B to O is going to be this flipped, so that's going to be minus 16j. O to C we know is 50i plus 136j. This time we're going to subtract the j component, so this becomes 50i plus 120j. Okay, so here we're timesing by 5, and here we are actually also timesing by 5. Therefore, we have some sort of scale factor. So that means that BC must equal to 5 of AD. Therefore, parallel. Cool. And essentially, you're looking for this scale factor. Perfect. Points A, B, C, D are used to model the vertices of a running track in a shape of a quadrilateral. Runners complete one lap by running along all 4 sides of the track, and the sides of the lengths are measured in meters. Given that a particular runner takes exactly 5 minutes to run 2 laps, calculate the average speed of this runner, giving the answer in kilometers per hour. So what I'm going to do for part B is I'm going to redraw or draw kind of what it might look like. Well, 12i, let's say 12i is here. 16j, let's say 16j is here. 50i plus 136j is, let's say, is like here. And then 22i is like there. Okay, so if that's A, that's B, that's C, and that's D, that essentially kind of connects like this, like so. Okay, well, we worked out BC already before, which was 50i plus 120j. Cool. And I'm actually going to work out this using Pythagoras, and this is actually a 5, 12, 13 triangle. But we can just work out what the length of BC is using some Pythagoras. So that is going to give you 50 squared plus 120 squared, and that should give you 130 actually. But yep, so it give you 130. So that means that this length is going to be 130. We can do the same thing with AD. Well, we know AD is 10 and 24. I believe it probably is a Pythagoras triangle as well, but I can't remember what the number is off the top of my head. 26. Okay, so that means that AD is 26. Cool. What two lengths are we missing? Well, we're missing C to D and we're missing A to B. Let's go ahead and work that out. For A to B, it's going to be the same thing as A to O plus O to B, which is the same thing as well, we're going to flip this around. That's going to be minus 12i plus 16j, and that's essentially it. And then we're just going to stick that into our calculator, work out the modulus of this. That's going to be I forgot the vector, 12 squared. The reason why I'm not including the minus is because essentially I'm lazy and it gives you the same answer anyways. But you know what, for the sake of the question, I'll include the minus. But you don't have to in terms of this. And that gives you 20. Cool. So A to B is 20. And since these are in meters, we don't necessarily need to care about the distances, I mean the directions. And let's do the same thing for C to D. C to D is going to be C to O plus O to D. That's going to be minus 50i minus 136j. So I've flipped my my OC vector, and then my O to D is just remains the same. And then let's go ahead and simplify this. 22 minus 50. That gives you minus 28i. And then I can do the same thing with the other 24 minus 136. That gives you minus 112j. And then we're going to do Pythagoras on this. Square root of 28 squared plus 112 squared. And that gives me 28 root 17. Ooh. Let me just double check that just in case if I haven't made a mistake. Because our other numbers are quite nice. Cool. Let's work with it. 28 root 17. So that means that in total what we have is essentially all our distances added together. So that's going to be 130 plus 20 plus 26 plus 28 root 17. So that's all our sides added together, and that gives us that number, 291.4 0.45, and this is in meters. Okay, so that means that if 291.45 meters is the whole track, what's its name? A particular runner takes 5 minutes to complete 2 laps. Okay, so if I times this by 2, and I'm actually going to convert this to into kilometers as well, and I can just do that by dividing by 1,000. Okay, so he's run 0.5829 kilometers in 5 minutes. Okay, so that's times by 2 because that's 2 laps. Okay, that's how essentially a distance and time. Well, the question is also asking us to work out in kilometers per hour. So I'm actually going to convert this to 5 minutes to an hour. How am I going to do that? Is just divide it by 60, and that gives you 1/12 of an hour. Well, how do we work out this speed now? Speed is equal to distance over time. That's going to be 0.5829 over 1/12. And I'm just going to take that divided by 1/12, and that gives you approximately 6.99 kilometers an hour. Let me just double check. Yeah, let's keep it at 6.99. Perfect. Question 7. A curve has an equation of dy by dx. Question 7. A curve has an equation of x cubed plus 2xy plus 3y squared is equal to 47, and we want to work out dy by dx. This is some sort of implicit differentiation. So when we're working out implicit differentiation, I'd say it's a pretty nice topic in my opinion. X cubed. Actually, you know what? Before we start, I'm gonna rewrite this. like so. Okay, let's get started now. 3x x cubed gets differentiated to 3x squared. This part here is actually a product rule, so I'm going to skip it for now. This part goes to 6y, differentiate like normal, and then we also have to multiply by dy by dx. Because whenever we differentiate y, using chain rule, you actually end up with dy by dx, because differentiating y essentially is dy by dx. Okay, that is a little bit of chain rule. It's equal to 47 differentiates to 0. Now this middle bit here, 2xy, this is a product rule. Now product rule, you have to learn the formula for it, but I'm going to show you this essentially thing I've learned. If you watched Pure 1, I've used it in there. F prime g plus fg prime. Essentially this just represents two functions that are being multiplied together, and this is the differentiation of essentially fg. So two functions, f of x times by g of x. In this case, f of x, or f, I'm going to say f is going to be 2x and g is going to be y. So that means that f prime, or when you differentiate f, that gives you 2, and g, whenever you differentiate g, again, that's going to give you, in this case, dy by dx. And following this formula, or in a really, really easy way, essentially it gets kind of cross multiplied. And this will give you 2x dy by dx plus 2y. And I can kind of essentially move this up here, like so, and that is not necessarily our answer yet, but it's a good place to continue from. All right, now we've kind of differentiated this. I'm going to move all the dy by dx terms to one side. So actually, I'm going to move this to the side to have a bit of space for working. Okay, let me quickly rewrite this and make this look a bit more cleaner. There we go. I'm going to move all the dy by dx to one side. So this ends up with 3x squared plus 6y, nope, 3x squared plus 2y is equal to minus 2x dy by dx minus 6y dy by dx. Okay, so I've moved these two terms, because these are being multiplied by dy by dx, to the right hand side. I've just subtracted them, and then these two terms, I've kept them together. Okay, and then what I'm going to do is factorize out dy by dx. So this becomes 3x squared plus 2y is equal to dy by dx minus 2x minus 6y. And then we can just go ahead and divide. So we end up with 3x squared plus 2y over minus 2x minus 6y is equal to dy by dx. There are, you can write this fraction essentially in different ways. So if you've written your final answer like this, that's completely fine. If you've written your final answer like this, that's also completely fine. So essentially the minus, wherever the minus is, it can get distributed anywhere. It doesn't really matter as long as that minus is there. Okay, and that's essentially going to be your dy by dx. Part B of the question. The point P minus 2, 5 lies on the curve. Find the equation of the normal to the curve at P, giving your answer in the form ax plus by plus c is equal to 0, blah, blah, blah. Okay, so what I'm going to do is substitute this into here, because essentially what you're doing with this part of the question, because essentially what you're doing with the part of the question where it's asking for the normal, you're taking the dy by dx and we're going to work out the negative reciprocal. So whatever kind of graph you have that looks terrible, let's use this graph. Okay, let's say you work out the tangent of that graph using dy by dx. We're going to work out the negative reciprocal, and that will give us the normal. Okay, the normal is always going to be perpendicular to that tangent. That's what the definition of a normal means, perpendicularity. Okay, so I'm going to substitute minus 2, 5 into here, and that's going to give me 3 minus 2 squared plus 2 times by 5. I'm going to put the minus on the outside. 2 times by minus 2 plus 6 times by 5. This is going to give me 3 times by 4, which is 12, plus 10. Minus on the outside. Minus 4 plus 30. Going to simplify this. 22 over, can't forget the minus, 26. And we can probably simplify this to minus 11 over 13. Okay, cool. That means that our normal gradient, because this is our tangent gradient here, our normal gradient here is going to be the negative reciprocal, so that's going to be 13 over 11. Cool. Then we can just use y equals mx plus c, or if you really want, you can use y1 minus y minus y1 and so on. But since they want it in this form, we have to make sure we convert it in this form at the end. So what I'm going to do, I'm going to take this coordinate and substitute it into here. That's going to be 5 is equal to 13 over 11 times by minus 2 plus c. Let's begin to expand out. Let's move it here for a bit more space. That's going to be 5 is equal to minus 26 over 11 plus c. Therefore, your c value is going to be them two values added together. That's going to be 5 plus 26 over 11, which gives you 81 over 11. Perfect. And now our final equation will be y is equal to 13 over 11x plus 81 over 11. But we need to make sure we end up with this form here, ax plus by plus c. I'm going to times the whole equation by 11, so I end up with 11y is equal to 13x plus 81. I move everything to one side, so this becomes minus 13x plus 11y minus 81 is equal to 0. Okay, if you've written it like this as well, this is completely fine. Absolutely fine. Because it's a 0, you can just divide through this by minus 1. They're both the exact same equation. Okay, cool. Question 8. Question 8. You've got some harmonics here, and there are some, I guess, shortcuts of doing this. But I'm going to show you the base way, and with that way, I guess you can kind of skip some methods or skip some lines of working, because not every single part of it gives you the mark, but it will definitely help with your understanding of how to do harmonics. Anyways, all these type of questions, you'll have R cos and R sin. And in your formula book, using that, cos A minus B will give you the following: cos A cos B plus sin A sin B. So using this kind of identity, we should end up with the following: that this should be R cos theta cos alpha plus R sin theta sin alpha. Okay, just by putting R cos of theta minus alpha into here, you can derive with this part here. Okay, what I'm going to do is, above this equation, I'm actually going to write this down here. So this ends up with 2 cos theta plus 8 sin theta. And now I'm going to compare. Now you can see in both of these, I have a cos theta here, and I also have a sin theta here. So I can essentially say that this 2 R cos theta must equal to R cos theta. So R cos theta, R cos alpha must equal to 2. And similarly, R sin alpha must equal to 8. Now, if you've ever looked at the unit circle in any way or form, and to be fair, you don't necessarily need the unit circle, but let's say we square both of these. I end up with R squared cos squared alpha is equal to 4, and R squared sin squared alpha is equal to 64. If I add both of my terms here together, I end up with the following: R squared cos squared alpha plus R squared sin squared alpha is equal to these two added together, 68. And you can see I can begin to factorize out this. Ooh, I've got an identity here. Well, this identity is actually just 1. So I can just write R squared. Therefore, your R must equal to root 68. Okay, and a little quick way of doing this, essentially just take your original numbers. Okay, and essentially what you can do is you can do 2 squared plus 8 squared, and that gives you root 68. And that is essentially your R value. You can use that to speed up your working. Okay, this is actually what you would get the mark for, not all of this. Okay, now to work out your tan, I kind of spoiled it already. To work out your alpha value, you're going to be using the idea of tan. And essentially, that means that if you know that R cos alpha is equal to 2 and R sin alpha is equal to 8, what you can then use with that is R sin alpha divided by R cos alpha is equal to tan alpha. where that's going to be 8/2. Therefore, in this case, you end up with tan alpha is equal to 4, and you can just put into your calculator alpha is equal to, and it wants it in radians, inverse tan of 4, and that gives us 1.33, or 3 decimal places 1.323, 326, 1.326. Okay, that's going to be your value for alpha. Again, to speed this up, you can just do tan alpha is equal to 8 divided by 2, specifically from your sine on the top and your cos on the bottom. And as you do more of these, you can just find these shortcuts. These are actually what you're getting marks for. Okay, not this extra bit of working, and technically, actually, you don't get marks for this either. You only get marks for this. Okay, so that means that if we go ahead and rewrite our expression, we should end up with the following: root 68 cos of theta minus 1.326. Now, part B, the first 3 terms of an arithmetic sequence are this. I'm actually going to copy this down and bring this across. And here we go. So this is an arithmetic sequence, and you can see each time what's happening is you're adding sine x. Cool. Given that S9 represents the sum of the first 9 sequences, find the exact maximum value. Okay, so for arithmetic sequences, you're going to be using this formula: n/2, 2a plus n minus 1d. Well, in this case, n is just our amount of terms, so that's going to be 9. Our initial value is going to be cos x, because that's what it says here. Our difference in term is going to be sine x. And using these, we can sub everything into our formula, and we end up with 9/2. That's going to be 2 cos x plus 9 minus 1, that gives you 8 sine x. Oh, wait. This looks really, really similar to what we had in part A. Edexcel really likes to do this. Okay, they really like to link your part A to part B in some way. Okay, so because we already made this expression here, what I'm actually going to do is actually take this, what we already worked out, and just sub it into here. So I actually end up with 9/2 times by root 68 cos of theta, or in this case x, we should be using 1.326. And if I go ahead and expand this out, well, what is 9/2 times by root 68? That gives us 9√17. Cool, so this gives us 9√17 cos of x minus 1.326. Now the question is asking us what is the maximum value of S9, and this is essentially the value of S9. Now whenever you have a trigonometric graph, your trigonometric graph has a maximum value here and a minimum value here. Well, specifically, let's say this is a sine x graph, right? And specifically just sine x. Well, the maximum value of sine is 1, and the minimum value of sine is minus 1. But as soon as I say, let's say 3 sine x, well, your maximum value turns to 3, and your minimum value turns to minus 3. Okay, and that all depends on essentially your coefficient of your trigonometric graph, and this also applies onto your cos graph as well, because your cos and your sine are very, very closely linked. They just shifted across essentially. Okay, again, your maximum value is 1, minimum value here is minus 1. So all depends on your coefficient. So in this case, your maximum value, okay, is just going to be 9√17 itself. Okay, you just bring that across like so. And deduce the smallest possible value of x at which this maximum value of S9 occurs. Well, we're trying to find out, well, when is 9√17 happening? Okay, so this is essentially when, well, this is at its maximum. So it's asking us basically when is cos, any sort of cos, at its max? Well, essentially when your cos function is at 1. Right? Your cos function itself has to be at 1, so it doesn't really matter what's behind it. Essentially, what you're essentially saying is when this cos function, cos of x minus 1.326, is equal to 1, and then we can go ahead and rearrange and solve for x. And well, that's just going to be cos of minus 1 of 1. That gives us 0. So that means that x minus 1.326 is equal to 0, and that means that x is equal to 1.326. which is a very, very nice, pretty simple answer in this case. Okay, I hope that just makes sense. I'm just going to quickly repeat that. If you want to skip ahead to the next question, great. But essentially, if you want me to read, but essentially, you are saying that when this value here, 9 root 17, cos of x minus 1.326 is equal to 9 root 17. Okay, you are trying to find out what that value of x is, and you find that when you divide through by 9 root 17, you just end up with that same value. That's when this is maximum. Okay, when any sort of cos x value is 1, this is the maximum. When you have any sort of cos x, and this also applies for sin x as well, actually, like so. Whenever you have any sort of sin x or cos x is equal to -1, that's your minimum value. So if this was -1 up here, this would be your minimum value. Okay, that's how your -1 and 1s work in your trigonometric equations. Okay, question 9. We've got some parametric equations, and it's saying that show that the Cartesian equation for C is y equals a ln x plus b. Okay, so at the moment here we've got t plus 3, and first things that come to mind is either completing the square on this or potentially factorizing it. I'm going to start with completing the square, and if it works, it works. This gives me t plus 3 all squared minus 9 minus 16. That should give you minus 25. Okay, this is looking good because we have a t plus 3 here and a t plus 3 here. Now we need to combine these two, essentially these two equations together. That's going to be 6 ln t plus 3. All right. How can we go ahead and rearrange this for potentially t plus 3 on its own? So then I can just essentially substitute this into there. So let's do x plus 25 is equal to t plus 3. This will be all squared. And then I'm going to square root this. So this is going to be x plus 25. Square root of x plus 25 is equal to t plus 3. And then I'm going to take this into here. So this is going to be essentially 6 ln of root x plus 25. Now we don't need necessarily worry about the plus or minus because we can't really have a minus in our ln. So we're just going to take our positive value. Now the question is saying a factor, and we don't necessarily want any roots in here. So I'm actually going to rewrite this as 6 ln of x plus 25 to the power of half. And this will allow us to use our log laws. So this minus half can go the outside as a coefficient. So this is essentially going to be 6 times by a half, which is 3 ln of x plus 25. Okay, and that is going to be your Cartesian equation. Y is equal to 3 ln of x plus 25 for part A. Part B, the curve C cuts the y-axis at point P. Show that the equation of the tangent to C at P can be written in the form. So P, where is P? So it cuts. It cuts the y-axis at P. So essentially the y-intercept. Okay, so the y-intercept in this case will be when your x is equal to 0. So when x is equal to 0, that's going to be just y is equal to 3 ln of 25. Okay, that's our y-intercept. Cool. I'm going to make a box around this. All right. Actually, we do have an ln 5 here. So you know what? Before we move on, let's actually convert this to ln 5. Well, 25 is the same thing as 5 squared. So we can make this 2 on the outside. So it just becomes 6 ln 5. Okay. I'm going to make a box around this. Y-intercept. All right. Next, we need to work out the tangent to C. Well, we worked out a Cartesian equation. Y is equal to 3 ln of x plus 25. Now, this is essentially going to be using our rules of differentiating. What is dy by dx? Well, ln of x differentiates to 1 over x, and in this case, it's actually very, very similar. So this will differentiate to 3 times by 1 over x plus 25. Okay, the denominator, this is kind of your rules for chain rule for differentiating ln. The denominator essentially stays the same as your argument, and the numerator is going to be essentially what does the x plus 25 differentiate to? In this case, just 1. Okay, and this is the same thing as 3 over x plus 25. Perfect. Now what we need to work out is, well, what's the gradient? What's the gradient at that value of, or that point of P, which was 0, 6 ln 5. Okay, well, our x coordinate is 0. So that means that dy by dx must equal to just 3 over 25. Now we can make our equation. We have our gradient of the tangent, which is 3 over 25. We have our coordinate, which is 0, 6 ln 5. Okay, and this will just essentially be y equals mx 3 over 25 x plus 6 ln 5. The reason that why we can just do that because y equals mx plus c. C is your y-intercept. But to be fair, the question is asking us about ax plus by. So what I'm going to do is times everything by 25. So it gives me 25y minus 3x is equal to 6 times 25, 150. That'll give you 150 ln 5. And that should be your final answer. Question 10. We've got this f of x here, and part A is asking us to do some partial fractions in terms of k. So I'm just going to rewrite this here, like so. And then this can be split up into a over x plus 4 plus b over x minus 2. And using these partial fractions, we can just write this as 3k x minus 18 is equal to a times by x minus 2 plus b times by x plus 4. The reason we can do this is because these are all essentially below the same denominator. So essentially what we're doing is kind of creating a common denominator. This kind of comes into learning your partial fraction stuff. It is not necessarily needed, but you can see that this fraction here, this fraction here is exactly the same as this fraction here. That's the reason why we go and do this, but that's in a partial fractions topic if you go ahead and learn that. Anyways, when we're trying to solve for a and b, there are multiple ways to do this. One way is to go ahead and compare coefficients. I know that's quite a popular method. I'm going to go ahead and sub in an opposite value for this. So x equals 2, and this will cause this to essentially become 0. And if I sub in x equals 2 for everything, so I end up with on the left-hand side, this will be 6k minus 18 is equal to the following. Well, this is just 0. This is going to become 6b. Therefore, b must equal to k minus 3, which is equal to b. So I've just divided this by 6. And I can do the same thing for x is equal to minus 4. Y, so I can set this to 0 this time. So this becomes minus 6a on the right-hand side. On the left-hand side, this becomes minus 12k minus 18. I can divide this by minus 6 again. This will give me 2k plus 3 is equal to a. And I can rewrite my original partial fractions if it lets me, like so. Like so, and then this becomes 2k plus 3 over x plus 4 plus k minus 3 over x minus 2. And that is our partial fractions. Part B, hence find the exact value of k for which this integral here is equal to 21. So essentially what we're doing is we're doing the integral of these partial fractions here because this is f of x. So I'm actually going to bring this down for part B like so, and that means that the integral of this between minus 3 and 1 must equal to 21, and we're trying to solve for the value of k. So when we go ahead and do the integration of any sort of fraction like this, especially when we have an x on the denominator, this turns into a natural log. Okay, so when you have 1 over x and you do this integral, this becomes the integral of ln x plus c. Okay, similarly, what we can do is apply the same rule for this here. So this will become the integral of, so when you integrate it, this becomes ln of x plus 4, like so. But what we need to consider as well is on what's on our numerator. Okay, and I'm actually going to just stop at this point here. ln of x plus 4, and the reason why I'm using modulus is because you can't really have a negative number in your ln, but whenever you differentiate ln of x plus 4, you end up with 1 over x plus 4. Okay, why does this happen? It's because on the numerator, this will be the differentiated version of x plus 4. On the denominator, remains whatever's the argument here. And this is essentially your kind of your chain rule. And well, we can see that here we don't have 1 over x plus 4. We have 2k plus 3. So what I can do is our coefficient here, that means that I must multiply by 2k plus 3. Now remember, 2k plus 3 is just a constant, so it doesn't really matter. We can just multiply. Okay, and we can do the exact same thing for our next bit here. So this will be plus k minus 3 ln of x minus 2. and this is the integral of minus 3. Oh, sorry, should be this will be the limits actually. So this will be the limits between minus 3 and 1, and this equals to 21. So I'm going to start to substitute everything in. So I have 2k plus 3 times by ln of, well, if we start from, I don't know why I underline minus 3, that's going to be 1 plus 4, so that gives me ln 5, plus k minus 3, ln of 1 minus 2, which is going to be minus 1, but it's the modulus of it, so that's just actually ln of 1. Okay, and then I can apply the same rule with the minus 3, minus 2k plus 3 ln of this time minus 3 plus 4, which is going to be 1, okay, plus k minus 3 ln of minus 3 minus 2, that gives you ln of the modulus of minus 5, which is going to be just 5. Okay, and I'm just going to remove the brackets here like so. Cool. Now let's start to simplify some stuff. Well, you can see that we have an ln1 here. ln1 in your calculator, you should know that is just equal to 0. So I'm going to rewrite this like the following. So this becomes 2k plus 3 ln 5 minus, again this is 0, so this becomes minus k minus 3 ln 5 is equal to 21. I can factor out an ln 5, so this becomes ln 5 2k plus 3 minus k minus 3 is equal to 21. And then we can start to solve for k. So ln 5, if I factorize these or simplify these inside brackets, this becomes just k even, and 3 minus 3 plus 3 gives you 6, so this should give you k plus 6. Okay, this is 2k minus k, 3 minus 3 gives you 6, is equal to 21. K plus 6 must then equal to 21 over ln 5, and that means that k must equal to 21 over ln 5 minus 6. Okay, and that is the exact value, and you can leave it like this. Next question. Question 11, we've got some differential equations. A tank in the shape of a cuboid is being filled with water, and we've got some measurements. At time t after water started flowing into the tank, the height of the water was h meters and the volume in the water was v meters cubed. In a model of the situation, the sides of the tank have negligible thickness and the rate of the change of v. Ooh, okay, so this part is actually very important. So whenever you see the word rate, the rate of change of v is inversely proportional to the square root of h. So I'm going to write this as dv over dt, because this is the rate of change of our volume, is inversely proportional to 1 over square root of h. So I can write this as dv over dt is equal to k over root h. K being some sort of constant, we don't know. We're just going to keep that, and that may come in handy. Well, part A is asking us to show that dh over dt is some constant over root h, and we might be able to use this to help us out somehow. Let's see what we can work out. Okay, when we have a part A, and you can see we have some information here, we should try to avoid that and only use what we've got here. Okay, well, we've got a volume. Okay, so if you ever have a volume like so, try to make a formula of the volume. Sometimes a formula is kind of given to you, but in this case it's just pretty simple, to be honest. We have base times by height, or sorry, I should say base times by depth times by height, and we should really be talking about this liquid in this case. That's going to be 20 times by 10 times by h. Okay, so that's going to be 200h in this case. Okay, from this I'm going to work out dv over dh, and that just gives me 200. Okay, the question's asking us, well, work out dh over dt. Well, dh over dt, if we make some equations using the stuff that we have, well, that's going to be dh over something times by something over dt, right? Well, which variable haven't we used yet? We haven't used v at the moment, so we're probably going to have dv here, and we're going to have dv here. Cool. Well, dh over dv, we have dv over dh, but we can kind of just flip this around. Therefore, dh over dv must equal to 1 over 200, right? Because we already have this here. And dv over dt, we already worked this out at the beginning, is just k over root h. and this is just going to equal to k over 200 h. Or you can say this is k over 200 over root h, like so. And essentially, because k is a constant, that means that this numerator is a constant. Therefore, this is some lambda. We don't know what that lambda is because we don't have the value of k over root h. Okay, and we've proved that there's some constant on the numerator. Therefore, dh over dt must be some constant over root h. Given that initially the height of the water in the tank was 1.44 meters, exactly 8 minutes after water started to flow in, the height of the water was 3.24 meters. Use the model to find an equation linking h with t, giving an answer in terms of this. So what I'm going to do is move all the h's to one side, and then move everything else that's not h to the other. And you'll see what I mean by that. So I'm going to multiply by root h on both sides of the equation. So I end up with root h dh over dt is equal to lambda. Okay, now these differential expressions, they kind of act like fractions, but they're not fractions. But what I'm going to do is times by dt on both sides. So I end up with root h dh is equal to lambda dt. And now because we have dt and dh here, and what we can kind of do is essentially call these integrals. Now we can kind of begin to integrate. So root h is the same thing as h to the 1/2. And I'm just going to integrate this, so this becomes h, I don't know why I put ln, h to the 3/2, and this will be 2/3, is equal to lambda t plus c. The reason why I'm not putting plus c on the left hand side is because there's a constant here and there's a constant here as well. So I can kind of just move the constant to one side of the equation and just call it plus c. Cool. We have some information here. It says initially the height of the water in the tank was 1.44. So that means that when t is equal to 0, your height is equal to 1.44. So that's going to be 2/3 times by 1.44 to the power of 3/2 must equal to c. And if you just stick that into a calculator, this gives us 2/3 times by 1.44 times by to the power of 3/2. That's going to be 144 over 125. That is the value of our c. Okay, that means we can rewrite this equation here. 2/3 h to the power of 3/2 is equal to lambda t plus 144 over 125. I think it was. Yep. And now we can use this part here. When t is equal to 8, our height of the water is 3.224. What I'm actually going to check is our time, just in case if it's not in seconds. Time is in, I believe it is minutes. Yeah, at time t minutes. Okay, cool. So when t is 8, our height is 3.24. Cool. And then we can start to work out lambda. So we end up with 2/3, 3.24 to the power of 3/2 is equal to 8 lambda plus 144 over 125. And if you go ahead and rearrange this for lambda, I'm going to just do this in kind of one step in my calculator here. So this is my height here. I'm just going to change this to 3.24, and then I'm going to subtract my 144 over 125, and then I'm going to divide by 8, and that will give me my value for lambda. So lambda must equal to 171 over 500. Cool. And then I'm going to rewrite my original equation once more. And this gives me 2/3 h to the power of 3/2 is equal to 171 over 500 t plus 144 over 125. Now the original question is asking us to give it in just terms of h to the power of 3/2. So I'm going to times everything by, or you can divide everything by 2/3, but essentially times everything by 3/2. Why? So we end up with essentially 1 as our coefficient here. So this becomes h to the power of 3/2 is equal to 171 over 500 times by 3/2 gives us 513 over 1,000. I'm going to write that as a decimal, 0.513 t plus, what is that as a decimal, 144 over 125 times by 3/2 as well. That is 1.728, and that is our full 5 marks. Part C of the question, hence find the time taken from when the water started flowing into the tank for the tank to be completely full. So essentially we're trying to find out when the height of this cuboid is going to be 5, or of this liquid is going to be 5. Okay, so what I'm going to do is, again, once more, write the original, or well, we've got the equation here. We're going to do h is equal to 5, and we're trying to work out the time. So that's going to be 5 to the power of 3 over 2 is equal to 0.513 t plus 1.728. And then we're going to rearrange. So I can just put it right into my calculator. So that's going to be 5 to the power of 3 over 2 minus 1.728. And you should really put this down as working as well. It's just me being a bit lazy here. Okay, and then divide your final answer by 0.513. And that gives you 18.43 minutes. Is your final answer. Perfect. Question 12. We've got a modulus graph looking question. The number of subscribers to two different music streaming companies is being monitored. The number of subscribers NA in thousands to company A is modeled by this equation, and then similarly to NB. Okay. Figure 2 shows a graph, sketches of the graph over a 5-year period. Okay, find the initial difference between the number of subscribers to company A and the number of subscribers to company B. So we're finding essentially the difference between these two. So, well, NA, when time is equal to 0, we're just going to put time is equal to 0 into this equation here. And we essentially get the modulus of minus 3 plus 4. That's going to be 3 plus 4, which is going to be 7. So we have 7,000 originally here, because remember, it's being measured in thousands. Similarly, for NB, we're going to sub in t is equal to 0. So that's going to be 8 minus the modulus of minus 6, which is going to be 8 minus 6, which gives you 2. And remember, it's being measured in thousands, so therefore 2,000. Okay, and since we're finding the difference between them, we're going to have 5,000 subscribers between them. Okay, cool. When t is equal to t, company A reduced its subscription prices and the number of subscribers increased. Suggest a value for t, giving the reason for your answer. So here you can see that NA, or company A, goes down and then it goes up. So I would assume that this point here, this lowest point, can potentially be t, because that's the lowest point of company A, and then after that your subscribers begin to increase again. Okay, and there's the way to go about this is essentially you have two. You can argue that there's two linear graphs here. You have one linear graph that's going down, so this has a negative gradient, and this has a positive gradient up here. So essentially what you can do to work out this coordinate here of t, you can take this modulus here of t minus 3, and you can create two different equations. So you can have t minus 3 plus 4, and you can have minus t minus 3 plus 4. So you have two different equations here. This equation is going to be t plus 1, and this equation here is going to be minus t plus 3 plus 7, which is going to be plus 4, which gives you plus 7. Okay, so essentially this graph, or this linear equation, represents this downwards bit here, but it also continues on like so. And then this t plus 1 represents this graph here. And essentially what you're finding out is the intersection between these two linear graphs, which essentially is that point that we've kind of outlined already. Okay, so if I equate these two together, so this means that I end up with 2t plus 1 is equal to 7. That means that 2t is equal to 6. Therefore, my time must equal to 3. Okay, is it in years? What is it in? Time is given in years, so this will be t3 equals 3 years. And then it also asks us for the explanation. I think giving a reason for your answer, because lowest amount of subscribers of A at this time. Cool. Question C. Find the range of values for t when NA is bigger than NB. Okay. Well, NA, I think it's a good idea to have a highlighter in this case, and you are allowed to use a highlighter in your exam, just not for your final answers. Well, NA is this V-looking graph here, and you're basically looking at when is this graph higher than NB. Well, you can see that NA is higher here and higher here. Okay? So, we need to essentially work out the key values here, or the key points. What are these two intersection points? Okay, we already kind of looked at, well, what are our two lines of equations, two straight line equations that the modulus graph consists of. Well, our NA, this part here, I'm going to make a little note of it here. This is going to be minus t plus 7. This is going to be t plus 1 going up. Okay, and I'm going to do something very similar with NB, and this will help us work out these intersection points. Well, NB, we're going to have 8 minus 2t minus 6, so you just keep it the same. And then we change the minus to a plus, like so. The reason why we do that and why we can do that is because of the modulus. That's how it kind of works. It turns all your negatives to positives, and that allows your minus and plus to essentially kind of change. If I go ahead and expand this out, this becomes minus 2t plus 14, and this will be 2t plus 2. Okay, this bottom one here has a positive gradient, so that means that this one must be 2t plus 2. Let me write that a bit more neater. 2t plus 2, and then this downwards going one must then be a minus 2t plus 14. Okay, and now we can kind of begin to see, okay, which intersection points do we need to work out? Well, we have an intersection point between minus t plus 7 and 2t plus 2, and that's going to be this first point here, and I'm going to call this point, let's call it x, and we're going to call this point y. Okay, so for point x, okay, that's going to be, let me look up what the equation, minus t plus 7 is equal to 2t plus 2. Okay, and then for point y, you have t plus 1 is equal to minus 2t plus 14. And we're going to work out the values of time for each of these. Going to rearrange this, so this ends up with 3t is equal to 5, therefore t is equal to 5 over 3. Here, this is going to be 3t is equal to 13, therefore t is equal to 13 over 3. Okay, now this part here, you can see that before, if this part here is 5 over 3, we want to go left to work out this region here. So it's going to be between 0 and 5 over 3. Okay, so this part is going to be 0 is less than t is less than 5 over 3. And I should probably put an equal sign here. Okay, and the reason why we don't put an equal sign here is because it says NA is bigger than NB, not equal to, so we don't need it here. The reason why we can use equal to on our 0 is because at 0 it is still bigger than. Okay, and then something similar to here. Well, this point here we've calculated as 13 over 3. Okay, but you can see our biggest value is just 5, so it's going to be between 13 over 3 and 5. So it's going to be 13 over 3 is less than t is less than equal to 5. And at 5 we can have it. The company A will again still be bigger than company B. So to convert it to set notation, we're going to put t is real, and we should probably leave them as like separate inequalities. So with a squiggly bracket like so, that is horrendous. There we go. A straight line, 0 is less than t is less than 5 over 3. Okay, or again we do the exact same thing. I don't like this. There we go. T is real. Line 13 over 3 is less than t is less than equal to 5. Okay, and that is going to be our final answer. Part D, state a limitation of the model used for company B. Well, when you time, you can see that at 5 years, this is just over 5 years, but eventually what happens is that this graph will continue to go negative. And you can see that at this point here, this value of time, we don't know what that value of time is. Maybe we can figure it out. But you can see that this graph will eventually go, will become negative. So for part D, you can say as time increases, company B, subscribers will become negative. Okay, and that's why this can be a limitation. Therefore, your model may not be suitable, or the model should be potentially different. Question 13. Part A is asking us to do some binomial expansion with a power of -2. Okay, Now, I know some teachers teach this a bit more differently to how I teach binomial expansion, especially with the negative power and fractional powers. So I'm actually going to quickly brief over of how this method, which is my method, kind of works. It's very, very similar to the formula book method, to be honest. It's very, very similar, but it doesn't require any sort of expanding out or anything. And this essentially works with whatever, factorizing. Question 13. Find the first three terms in ascending powers of x of the binomial expansion of this. Okay, so when I teach binomial expansion, and I've showed this on my TikTok as well, and to my students that I've taught, it's a bit different to how teachers normally teach. The way I do it, it does not require any sort of factorizing within the brackets here, and this works for essentially every single power, whether it's positive, whether it's negative, whether it's fractional. Okay, it basically takes a year one method, and you basically do the method. It's very, very similar to the formula book. It's not much different, to be honest, but let's just do it. Okay, so I'm actually going to start with the Pascal's triangle, just to give you a bit of a reference. So this is the Pascal's triangle, right? And if you want to go ahead and skip, definitely go skip to the next part, or towards the end of the question, just to double check if you got the answer right. But this is your Pascal's triangle. Now, you can see that every single value at the start is 1, like so. The second is always that sort of what row it is in. So this is n equals 2, so this is your second row, and you can see that the second number, or you can say it's technically your first because this begins at 0, is always the same as whatever row you have. So this is n equals 3, so this is your row. The next one is n equals 4, n equals 5. You can see that, right? So essentially, we can kind of generalize this like the following. So if every single binomial coefficient is given by NCR, we can say that NC0 must always equal to 1, because that's our first ones, and NCN, no matter what, NC1 should always equal to n. Okay, so that first term in here should always equal to whatever row you have. Okay, and we can use this idea to help us with this. Okay, now the question is asking us about the question is asking us about the first three terms in ascending powers. I'm going to rewrite the binomial expansion here. Okay, so this is how we're going to do this. We're going to start off with the binomial coefficient, and I'm going to put these both in brackets. I'm going to put 3 here and x here. Now, since we're starting with since we're starting with ascending, this is going to be 0, and this is going to be actually the same number as this. And you might notice that these two powers should add up to the same amount here. Cool. Next, -2, choose 1. Exact same thing. We're going to increase the power by 1. Remember that your powers should add. Remember that your powers should add up to -2. So this has to be -3 here. And you can see that essentially we'll add 1 here, we'll take away 1 here. And this also applies to your fraction stuff as well. Okay, and this should be your next powers. And we only want 3 terms, so this is where we're going to stop. First one is pretty simple. Remember, anything choose 0 is just 1. It's going to be 1 times by 3 to the -2. And x to the 0 is just 1 as well. So this actually just gives you 1/9. Very nice. Next bit, -2 choose 1. Well, this is just going to be -2 times by 3 to the -3 times by x. The reason why you can't do minus numbers and fractions in your calculator is because it just ends up working with infinities. So that's why we kind of have to do it manually, which is okay as well. But I'll show you how to kind of do this next part in your calculator, which will be nice. But -2 times by 3 to the -3. If I just stick that into the calculator, -2 times by 3 to the -3. That gives you -2/27. X. The next part, -2 choose 2. Now this one's slightly different. And this kind of, you can use your formula book to help you with this, but essentially, this formula here, you might recognize, you might not, is your binomial function formula. Now whatever you have on the top, so in this case our n is going to be -2, Well, our n is going to be minus 2 factorial. Our r is going to be 2 factorial. And n minus r, that's going to be minus 2 minus 2, which is going to be minus 4 factorial. Okay, well, if we go ahead and kind of rewrite this like the following, minus 2 times by minus 3 times by minus 4, and so on, well, this part here, we can actually write this as minus 4 factorial all over 2 factorial times by minus 4 factorial. You can see this ends up cancelling out, and what we're left with is this. And to make this a bit more easier to remember, rather than just putting it into your formula every single time, an easy way to remember essentially is on the numerator will be the amount of terms that we have. So we have, you can see minus 2 choose 2, so we're going to have 2 terms on the top. Okay, and on the denominator, we're just going to have 2 factorial. And this is just going to give you 6 divided by 2, which is 3. So that gives you 3 times by 3 to the minus 4 times by x squared. And we can stick that into a calculator like so. And that gives you 1 over 27 x squared. And that's going to be your full expansion. If you want to practice this method and see how this kind of works, I'll give you a couple more, okay, real quick, and you can skip ahead for those who are not interested. It's completely fine. And this should be your full expansion. Okay, if you were to do minus 2, choose 3, minus 2, let's do minus even 4, choose 2. Okay, pause the video, try this. Well, this one's going to be minus 2 times by minus 3 times by minus 4 on the numerator. Why? Because we have 3 terms. Divided by 3 factorial. Well, 3 factorial is the same thing as 3 times by 2. We can start to cancel out some stuff. And we're just left with minus 4. So that means that minus choose 3 is equal to minus 4. Exact same thing with this one here. Minus 4 times minus 5. All over 2 factorial. That gives you minus 20 divided by 2, which is 20 divided by 2, which is 10. So that is minus 4 choose 2. You can also apply this with fractions here. So a half choose 2. So it's going to be a half times by minus a half. Remember, you're minusing 1 each time. Okay, divided by 2 factorial. This gives you minus 1 over 4 divided by 2, which gives you negative an eighth. Okay, if you like this method better, then use it. Part B. Using the answer to part A and using algebraic integration, estimate the value of this. Okay, and what I'm going to do is actually rewrite this like so. So we have the integration of 0.2 and 0.4. Okay, and I'm going to quickly rewrite this as the following: or 6x times by 3 plus x to the power of minus 2 dx. Well, we already worked this out here as this. So I'm actually going to rewrite this as the integral of 0.2 to 0.4. Let me just check the limits. Have I copied them correctly? Yeah. And then I'm going to copy across my binomial expansion that I just worked out. That's going to be 1/9 minus 2 over 27x plus 1 over 27x squared dx. And now we can just expand this out. That's going to be 0.2, 0.4. That's going to be, I could even factorize out the 6, to be fair. You know what, let's factorize out the 6 just to make it a bit more easier. Like so. So this becomes 6 on the outside, 1 over 9x minus 2 over 27x squared plus 1 over 27x cubed dx. And now you can see this can integrate very, very nicely. And this is going to go to 6, we'll multiply by 6 right at the end. This is going to go to x squared. Our limits are here. And this will be 1 over 18 x squared. Minus this will be x cubed. This will be 2 over, what's 27 over 3? Oh, sorry, 27 times by 3. 60, 21. That gives you 2 over 81. Okay, and then this is going to be x to the power of 4. Plus 1 over 54, 108, I believe. And that's your binomial expansion. Sorry. And that is your integration. And then we're just going to sub in our limits. This is going to be, or we can even times by 6 now, to be fair, we could. But you know what, let's leave it for now. We have 6. We're going to sub in all our limits. So it's going to be 1 over 18, 0.4 all squared, minus blah, blah, blah. Okay. Minus 1 over 18, sub in 0.2, blah, blah, blah. Okay, and then we can just kind of sub this into our formula book. I don't know why it's a formula book, my calculator. And then that's going to be 1 over 8. In fact, I'm going to use 0.4 like that as our answer. 1 over 18 answer squared minus 2 over 81 answer cubed plus 1 over 108 answer to the power of 4. And that gives us this number, which is wild, 382 over 50625. 382 over 50625. And we need to subtract the number with 0.2. I'm just going to quickly change that top bit to 0.2. And this goes to 413 over 202,500. I think this would probably work a bit more nicer if we times by 6 earlier on, but it doesn't really matter. Okay, and let's quickly subtract 382 over 50625 minus the answer that we've just got. And that gives us this number here, which is 223 over 40500. That's going to be 223 over 40500. And we need to times this answer by 6. So we can just do times by 6, answer times by 6, and that is 0.033 or 223 over 6750. Quite a lot for 4 marks. It's a bit annoying, it's a bit tedious just because it's not necessarily hard, in my opinion, but it's just accuracy, I would say. Alright, part C. Find using algebraic integration the exact value using this, and we are asked to work it out in terms of give our form the final answer in terms of ln. I'm going to take a screenshot of this and let's move it down. Cool. Well, the first thing that kind of comes to mind is potentially using integration by substitution, just because you can see that here x doesn't necessarily differentiate back to 6x. So I'm going to do u is equal to 3 plus x. Okay, now whenever you make a substitution, I would recommend that you just go ahead and differentiate it anyway. So that means that du over dx is just equal to 1. And therefore that du must equal to dx. Okay. Now while you're doing your substitution as well, let's change our limits. Right now our limits are x limits. So if I sub in x equals 0.4 and x equals 0.2, that means my two new limits are going to be 3.2 and 3.4. Okay. Cool. Let's start to substitute some stuff in. So we have the limit, the integral of between 3.2 and 3.4, 6x over u squared du. But we have a problem here right now. We have 6x on the numerator. We don't want an x. So what I'm going to do is take this substitution here and somehow rearrange this for x. So I end up with u minus 3 is equal to x. Well, therefore, I can rewrite this as 6 times by u minus 3 over u squared du. I'm going to expand this out, so I end up with the integral of 3.2, 3.4. In fact, we can even move the 6 out, but you know what? Let's just keep it there for now. 6u minus 18 over u squared du. And you can see now the u squares can actually divide very, very nicely for each of the terms. So we end up with 6u to the minus 1, because we have our power is 1 here. 1 minus 2 gives you minus 1. And then the other bit can be minus 18u to the minus 2. Okay, if you're unsure how I went from here to here, I kind of essentially just separated the fractions like so. Okay, and you can see that this goes to there, and it's going to be du. Cool. And now we can go ahead and integrate this. 3.2 to 3.4. The limit should really be on the right hand side, but it doesn't really matter. Okay, I'm actually going to rewrite the 6u to the minus 1 as 6 over u, just so it's a bit more easy to see what this integrates to. Well, when you have an over u, it actually goes to ln of u. Okay, and then we'll just put a big 6 in front of it, because that's our numerator here. And then this one's going to go to u to the minus 1. Minus 18 divided by minus 1 gives you plus 18. And that's it, really. I'm going to write this as 18 over u. Now let's start to substitute some limits in. We end up with 6 ln of 3.4 plus 18 over 3.4 minus 6 ln of 3.2 plus 18 over 3.2. I'm going to simplify these fractions later on. So this becomes ln 3.4, 6 ln 3.4 minus 6 ln 3.2 plus 18 3.4 minus 18 3.2. Okay, so essentially what I've done is I've distributed the minus for each of these, and I've just kind of combined the ln's together and my constants, my numbers here together. Okay, well, 18 over 3.4 minus 18 over 3.2 is that, which is minus 45 over 136. Cool. And then this part here, well, because we are subtracting our logs, or our natural logs in this case, it's going to be 6 ln of 3.4 divided by 3.2. Okay, and what does that simplify to? Well, 3.4 over 3.2 is going to be, I believe, 17 over 16. Yeah, 17 over 16. And that is our essentially our final answer. 6 ln 17 over 16 minus 45 over 136. Cool. Question 14. We've got a trigonometric identity question. And I think this was one of the hardest trigonometric identity questions that Edexcel has given for A-level. Just because I think it's a lot of accuracy work here and a lot of identity work. Well, I noticed two things just by looking at part A. This and this. Okay, I'm going to talk about 23 sine squared first. Okay, because it says this may be written as sine squared theta, we have a cos squared, cos, and a c. Well, you can see that this is a sine squared and we have a cos here. Chances are we probably have to use some sort of identity to convert 23 sine squared into cos squared. And what I'm going to do with that actually straight away, let's do sine squared plus cos squared is equal to 1. And I'm going to rearrange it for cos squared. So that means that, actually I'm going to rearrange it for sine squared, so I end up with sine squared is equal to 1 minus cos squared. Therefore, 23 sine squared must then equal to 23 minus 23 cos squared theta. Okay, so I'm going to write this original equation like so. 2 tan theta times by minus 23 cos squared theta plus 8 cos theta plus 23 is equal to 8 sine 2 theta times by this part here. Now this is also an identity. This identity here actually is derived from this original one here. So if I divide this whole equation through by cos squared, each term divided through by cos squared, I end up with tan squared theta plus 1 is equal to sec squared theta. So I'm actually, instead of writing 1 plus tan squared theta, I'm going to write down here sec squared theta. Cool. Perfect. Let's see where we can also take this. Okay, with this 2 tan theta, I'm going to rewrite this as 2 sine theta over cos theta. And then this part here, we can just copy across like so. And then what we have here is 8 sine 2 theta. Now this is your double angle formula. I recommend that you learn it, but you can derive it from your formula book. Sine 2 theta is the same thing as 2 sine theta cos theta. Cool? And therefore, that means that this must equal to then 16 sine theta cos theta, because we're just timesing this by 8. Okay? And then sec squared theta is the same thing as, let me just move this out of the way real quick. This is the same thing as times by 1 over cos squared theta. Cool, and I'm just going to put this as a denominator like so. Alright. What I'm going to do is times this whole expression by cos squared. And the reason why I'm doing that is so I can get rid of this denominator. Okay, I'm going to times the whole thing by cos squared. So I end up with 2 sine theta cos theta times by this plus 8 cos theta plus 23 is equal to, well, we've just times by cos squared, so this essentially can get, the denominators can get cancelled out. Okay. Well, this is looking good right now because now we have some sort of sine theta cos theta, and we know sine 2 theta is equal to sine theta cos theta. Okay, we're able to use that identity. Okay, I'm going to essentially move this whole expression onto the right side, or you can move it to the left side as well. That doesn't really matter. I'm going to move it to the right side, so I end up with 16 sine theta cos theta minus 2 sine theta cos theta times by this plus 13 is equal to 0. Next, what I'm going to do is convert these back into the sine theta kind of identities. So this becomes 8 sine 2 theta minus sine 2 theta, and then we can write this formula again. And then, we need to think about, how we can combine these two together. Well, you can see that, actually what I'm going to do is I'm going to call this expression here, for now, let's call it k, like a big K, just so it's easier to factorize because I don't want to keep on writing it again. Okay, so let's just call that k for now. Okay, so 8 sine 2 theta minus sine 2 theta k. Okay, I'm going to factorize the sine 2 theta out. So I end up with sine 2 theta factorize out 8 minus this k. Alright, well now we have a sine 2 theta on the outside. Well, we have this whole expression here. Well, since this is minus k, we just have to be careful because this would be in brackets. So this is going to be sine 2 theta brackets 8 minus, well, you're minusing all of this. So minus 23 cos squared theta. So that becomes plus 23 cos squared theta. Then you have minus 8 cos theta. So that becomes minus 8 cos theta. And then minus 13, like so, is equal to 0. Remember, this is equal to 0. Just from before. Okay, and then we're going to do minus 13 plus 8 just to simplify. Okay, and then this should give you, let me just double check. Whoa, I've copied some stuff wrong. This should be 23 here. Oops, that should be 23. I've miscopied my my numbers, so yeah, be careful about that. So this should be 23 as well. This means that this part's 23. And that's why accuracy is very, very important. Minus 23. And then minus 23 plus 8 should then give you sine 2 theta, 23 cos squared theta, minus 8 cos theta, minus 15 is then equal to 0. Perfect. And that's part A complete. And then hence, solve for 360 is less than equal to x is less than 540, for where we have essentially this. The only difference I can see between these two equations is that the thetas have been converted to x's. So essentially what we're doing for part B is essentially solving what we've got here. So we essentially are solving sine 2x, 23 cos squared x, minus 8 cos x minus 15 is equal to 0. Therefore, we end up with two equations where sine 2x is equal to 0, or 23 cos squared x minus 8 cos x minus 15 is equal to 0. Cool. Therefore, well, let's start to rearrange or do inverse functions. So we have sine to the minus 1 of 0, where we end up with, which is just 0. Cool. That's kind of our primary value. And then, actually, before you even go ahead and solve this, what I'm going to do is actually adjust our, okay, and then for this one here, we're going to have, let's try to see if it factorizes or if there's any sort of solutions. I'm just going to put this quadratic into our formula here, like so. And then we end up with actually two values of minus 15 over 23 and 1. So that means that cos x is equal to 1 and cos x is equal to minus 15 over 23. Cool. And now let's solve for x for these two values. So that means that x is, and remember this is going to be in radians, okay? You have to be in radians for this because since you're working in terms, and always just double check, is it in radians, is it in degrees? In this case we are working in degrees, so I'm going to quickly change my calculator to degrees because I think I am in radians. Yeah, I'm in radians. Let's quickly change this to degrees. Okay, so cos of 1, cos cos of 1 is also just 0, and what we have here for the last one, inverse cos of 15 over 23 minus 15 over 23 gives you 130.7. Okay, now we need to work out what is the values in our range specifically, because this is between 360 and 540. Okay, now there are multiple ways of doing this. You can draw a graph if you want to. You can draw a unit circle. I'm going to use a unit circle for this part. Well, we've got 2x is equal to 0. Well, actually, for this part here, we should really adjust our range, because since our range is between x only, that means that this is actually going to be between 722x and 1080. Okay, so we should take account of this sort of inequality when we're trying to work out for sine 2x. I'm actually going to write this down here, like so. Okay, so if we know that every, well, for our sine graph here, this is 0. Okay, well, when does it hit 0? Well, essentially when you have some sort of symmetry in terms of your of a unit circle, but you're also going to have one on the opposite side. So actually you're going to have a 0 technically here as well. So essentially you're going to have 1 at 0, 1 at 180, 1 at 360, and so on. In this case, every time it hits 0, it's going to be every 180 degrees. Okay, but we want between 720 and 1080. Okay, so there is actually going to be one at 720, because you can see this is kind of a factor. So 720, there's going to be one. Let's keep on adding 180. That gives you 900, and then the next one would be 1080. Okay, so we don't care about these three, but these three here are the relevant ones. Therefore, if we go ahead and divide these three numbers by 2, that means x must equal to 360, 450, and 540 for this. Okay, we can do the exact same thing for cos. Okay, and if I go ahead and draw the cos graph instead of using a unit circle, let's use a cos graph. Okay, well, we can see that the cos graph is at 1 specifically when x is equal to 0 and when x is equal to 360. So here the revolution will be 360, and obviously we're looking between our range, which is 360 to 540, and since this revolution is every 360 degrees to hit 1, the only valid value will be 360, so therefore here x is only 360. Okay, and here we can again use a graph, or we can use a unit circle. This time I'm going to use a unit circle because why not? But essentially we want 130.7. So 130.7 is essentially this is going to be this angle here. Okay, but which kind of reflection are we using? We're going to be going to the downwards reflection. This is because when we're using cos, it's kind of a reflection in the x-axis. Okay, you can think of it as there are some videos on unit circles, and eventually I will make some videos of unit circles in depth. But this is how we can go about working this out. So that means that this angle here must also be 130.7 degrees. Okay. Well, we need to work out essentially. Well, we've got our first value here. Cool. What is this angle here? Well, that's essentially going to be 360 minus 130.7. We can stick that into our calculator, like so. And we've got 229.29. Okay, but once you've got your first two pair values, you can actually start to add 360 to both of them, because there only exists two pair values. So you can add 360 to both of these, and that will start to give you some more values. So if I add 360, 589, 949, so this would be 589.9 and 949.9. Okay, for the right hand side, and we can do the same thing for 137 plus 360. Okay, so I've essentially kind of just put it right into my calculator like so. Yeah, and with the CG50 there is actually a nice calculator method as well to double check, and I'll quickly show you that afterwards if you like to stay for that. Okay, so then here our two other values for this would be 490.7 and 850.7. 490.7, 850.7. Which two ones are we more interested in? Well, we're interested between 360 and 540. Okay, so that's going to be these two. Actually, just even one, because it's not between 540, so it's only going to be this one. That means our final answers are going to be 360, 450, 540, and 490.7, like so. But what we should also do with these answers is just double check, are these answers all valid? Because in our original equation, we did have tan, as you can see, where tan is the same thing as sine theta over cos theta. So essentially what we don't want, if you go back into our tan here, we don't want cos theta to equal to 0. So if we draw our cos graph like so, okay, and you can see we have two places where the graph is at 0, where this is 270 and this is 90 degrees. Essentially, we don't want anything 90 plus 360 or 270 plus 360, any of these two numbers when we're adding the same revolution to be part of it. So 90, 270, we're good, we don't really care. But let's just check if we add 360 to both of these. This will give us 450, and this will give us 500, 630. Let's check if we have any of these values, and we do. So we can't actually have 450. So we only have three answers: 360, 540, and 490.7. Okay, so you can either do this method or just double check the answers that you have, sub it back into your original equation, maybe even up here or right up here, just in case, and check, does the answer actually work, or is there some sort of error that you may have? Okay, so these three are the only answers that you can have. Last question of the paper, and we've got some proof here. A student attempts to answer the following question. Given that x is an obtuse angle, use algebra to prove by contradiction that sine x minus cos x is bigger than or equal to 1. And he starts the proof with this. So assume that sine x minus cos x is less than 1 when x is an obtuse angle. And we have to essentially prove this. So we have to essentially prove this equation wrong, essentially. Okay. So what I'm going to do is let's start by expanding this out. Well, let's begin to expand this out first. So we end up with sine squared x plus, minus 2 sine x cos x plus cos squared x is less than 1. I'm going to combine these two together. Actually, before we do that, this is actually an identity in the middle. So I'm going to write this as minus sine 2x. So this is your double angle formula identity. Okay, and well, you have sine squared x and cos squared x. When we add them together, that's the same thing as 1, and it's equal to less than 1. So if I subtract 1 from both sides, we're saying that minus sine 2x is less than 0. And we can say if I divide through by minus 1, therefore sine 2x must be bigger than 0. Well, what values of x do we have where this is bigger than 0? Let's just go ahead and draw the sine 2x graph. Well, the sine 2x graph looks something like this. And essentially we have two revolutions between 360 degrees, or within 360 degrees. Okay, it's going to be 90, that's 180, that's 270. Cool. And obtuse angles essentially mean bigger than 90, but less than 180 degrees. Okay, and you can see that here, in this region here, that is negative. So you're saying that we show that, okay, sine 2x is bigger than 0 when, oh, my pen's not working, when x is obtuse. But here we have a contradiction where x is obtuse, this is negative. So this is a contradiction because sine 2x is actually less than 0 when x is obtuse. Therefore sine x minus cos x must be bigger than equal to 1. Okay, that's your contradiction proof complete. And that is the end of the paper.